Good evening all, and welcome to tonight's webinar by Texas Instrument Australia. We are very excited that you can join us this evening, and a Happy New Year to you if it's your first webinar. And I hope the school year has treated you well, and if you're watching it on demand, then whatever time of the year it is, I hope all's going well with you. So you're joining us tonight for graphing and using functions on your TI-84PlusCE with Isabel Hoadley and myself, John Bayman. I will be your host and panelist this evening. I teach mathematics to Year 7 to 12 students at Loughlin Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And I'm very excited to introduce a colleague of mine from Loughlin Catholic College, and our other panelist this evening is Isabel Hoadley. Good evening, Izzy.
Hi.
Izzy is a colleague of mine, as I said, up here in Darwin. She's a very enthusiastic and dynamic teacher. I have to admit that I am somewhat in awe of her biography and also her teaching. She is fantastic in the classroom, and students really appreciate her knowledge of mathematics and its integration with the technology that we use. She really is a professional in the classroom. So, Izzy, thank you very much for joining us this evening.
Pleasure.
So, with the introductions out of the way, let's get started. We are going to be using TI SmartView, which I do hope that you have available to yourselves in the classroom. If you don't, please either reply in the chat window, and I can organise that for you to get a 90-day trial of the software, or equally emailed TI Australia. There's a 90-day trial, and also there's the possibility of the volume purchasing program, where you get free, almost like Woolworths rewards for TI calculators, which is fantastic. So the OS, which you should have on your calculator, is the 5.3. And to find where it is on both the calculator and the SmartView, you simply go to Memory, About, and you should see that it should say 5.3 here. It may have a few different numbers here afterwards, but it's version 5.3. If not, it's really simple to update them. So normally when a new OS comes out, and obviously quite a few in the class need it doing, or you have a new class where they don't have that. They still want it done when you show them some of the tricks that you're going to do with it. Izzy's going to use one of the transformations apps today. She's also going to use images. So what I do is I have TI Connect on my desktop. You can see it on the right-hand side there, and I open that up. So this is what we're in there. That's TI Connect. That allows my calculators, handhelds, to talk to the computer. So I'll just turn that one on. You'll see the calculator will come up here. There it is. And I can, during a new class and a lot of students, I can have more than one connected. I've got one of those. I've got many cables, and I've got one of those multi-USB ports. I also downloaded the TI-84CE OS and Bundle app. Again, if you don't know how to find that, just have a search on the TI Australia website, or again, ask us, and we can show you. And then all I simply do is when the student's calculator is open, and we're not in screen capture mode, but in Calculator Explorer, I simply drag and drop it across. And it takes normally, with actually having the bundle rather than just the OS, it takes maybe a minute to do. And students really appreciate doing it that way. So I'm not going to do that now. And equally, I've also, if we want to do images, we do the same thing. I've got an image here, just literally just downloaded. I'll just show you it there. An image off the internet of a skier. Or see a snowboarder actually, and to do an image, which it is going to show in a minute, you do it exactly the same way. Again, I won't put that on for now. If we were using it on SmartView, so if we're using it in the classroom, and like I said, the smart boards that we now have in our school just really help to actually have it in this format and be able to press the buttons on the screen to show the students how to use the calculator. We do the same thing. We put it into the magnifying glass mode, and we grab the image and simply drag and drop it across. It really is that simple. So, Izzy, I know that you're going to show us how to use the Transformations app. So I'll pass over to you and look forward to learning how you use it in your classroom and sharing some ideas with our other participants tonight.
Cool.
I've just got to, oops, there's me not pressing the right button for you. I do apologise about that.
That's all right. Okay, cool.
Wait for me. Go on, come on now. You can do it. There we go.
Cool.
Izzy, fantastic. You can see your screen. It's all yours.
Beautiful. Okay, cool. So like John said, I'm just going to be talking a little bit about using the transformation graphing app first, which I think is one of the best apps available on the TI-84, particularly for teaching through stage 1 methods. But I'm also going to show an application that we could use for stage 2 methods as well. So if we go into the apps button on our TI-84, you'll see that there's a whole lot of apps in here. And the transform one is actually the very last app under this menu. So if we can either scroll all the way down to the bottom, or we can just go one up, and there it is at the bottom of our menu. So if we go into here, you'll come up with this screen. If we hit enter, and the way you can tell that the app's kind of up and running is if we go into our function editor, the y equals, we can see there that it says transformation graphing app, and you should have these two, the first two functions there with this kind of play pause button next to it, which is what the main function of the transformation graphing app is. Okay, so in here, one of the really nice things about this app is it does have a few kind of preset functions that we can use. So if you scroll across left twice so that you've got this box and the play pause button open, and you press enter, we can change the color of the graph. I don't want to do that now. We can change whether we want this on a kind of a play function or a pause function. Again, I'm going to go through that in a minute. And then under this Y1, at the moment it says no, but if you scroll across, we can see we've actually got a whole lot of general forms of some of the really common equations that we see in the methods curriculum. So I'm going to look at the turning point form of a quadratic. And I'm also going to look at, just for a comparison, the it's pretty much the turning point form, but just where we've got a dilation and a vertical translation as well. Okay, so I'm going to look at these two. Usually, if I was doing this in class with students, I probably wouldn't look at, wouldn't look at two functions at the same time, but it is a really nice feature of this app that we can compare two different functions. One thing I'm going to change here is that I'm going to change this B value to a C, just because, you know, I'm a teacher, so I know that these are both going to give the vertical translation, so I want to keep that letter constant, because otherwise we're changing different things at a different time. Okay, so I'm just going to hit graph. I don't think I've got a whole lot of stuff going on there that I need to change. Hang on a second. I knew I forgot to do something before. John, do you want to say anything just while I'm doing this? Have you used this in class?
I think there's some really great apps on the TI-84 that I think that a lot of teachers don't know about, and students definitely don't know about. The periodic table they really find useful to use in science. The general students at the moment are just using the linear programming app, which has some really nice features of it. And the nice thing is that all these apps, like I said, are free to download if they're not already in that bundle or not already on the handheld. But the guidelines to actually how to use them are on the website as well, and there's also obviously some tutorials that people can have a look at.
Beautiful, cool. All right, so I've got this all sorted. So we can see here that we have our the turning point form of our equation here, and then just the dilation and the C value here. And at the moment we've got A set up to 1, B set up to 1, and C set up to 4. I'm going to change that. So if I go into setup here, so to get to that setup button, we just hit graph. And we can see here we've got this trail on, trail off, pause, play, and a play faster. And we have our 3 variables down here. So I'm going to set all of those to the same value to begin with. So I'm going to set them all to -2.
Can I just say that it may just be worth changing the view just for a second to having the screen above the handheld. Although it's nice, obviously we use that with students. It's good to just show people where that graph button links to on the calculator.
Yeah, good point. Cool. So I'll just quickly say this. So we're just going to have that step set up to 1, and that means that every time we're going to increase, we're just going to increase one of the variables by 1. So like John said, you can see there that graph button, that's how we change in between the settings and the graph. So if I hit that again, that's going to take us back to the graph. And again, set up and graph the same there. So I'm just going to go back to the bigger screen because I think it's a bit nicer to look at. Cool. Okay, so now we should see that we've got our two functions, and our A value is the one that we're kind of currently changing. So if I go across to the right, I'm going to increase that A value by a step, which was 1, and we should be able to see that we've got that dilation that's happening there, which is really nice. If we go back into the setup, I'm going to play around with, instead of looking at A this time, I'm just going to change this to looking at C. So that's going to be our vertical translation. And if I hit enter on C, we now have that highlighted. So that's the one that we're going to be looking at. And this time, I'm going to use the play function instead of the pause one. So what the play does is it's going to run through, it's a bit like a GIF. So it's going to run through a set of screens and show every step kind of like as a moving image. So I'll make the max up to 3, so it's going to show us a total of 5 different screens. And then if I press graph again, 6 screens, we can see how that moves through. And again, if you wanted to run that a bit faster, you could use that double play button, but I usually find that that's enough. This is probably fast enough for students to look at. So we can see that vertical translation and it getting higher up in our screen. One of the things that students find really hard with this is getting back to using the setup again, because if you'll see, if we press that graph button again, it's actually not going to do anything. So what you need to do is you need to hit enter, and that's going to pause your screen, and then you can go back into editing the settings. Last thing I'm going to do is I'm just going to
it took me a long time to find how to do that, and I was like,
That's it. And if it takes you a long time, it takes the kids a lot longer. Last thing I want to show is just turning the trail on. And this is probably one of my favourite things, because sometimes I do find that if you're looking at it on play, it does run a little bit quickly, but that trail lets us see every screen kind of on the same one, but also that moving element as well. So now if we hit graph, we can see that it's moving, but it shows us what all of our previous translations did as well. Okay, so when I was kind of thinking about this, what I was going to say about the transformation app, other than just the fact that we can do the change the variables and look at the picture, is I wanted to talk a little bit about how you might use this in kind of a connection with some algebra. So this time I'm going to look at just the general form of a quadratic, so where we've got ax squared plus bx plus c. And I would kind of talk about this, I think, in connection with maybe just having just done quadratic formula with students and looking at the effect that each of the variables have on how many solutions that we're going to see in our equation. So I'm going to go, we can go into that settings part also just by pressing window from the home screen, from the y equal screen. So if we go into window and then just go across to settings, we can access that a bit faster. So good, all of those are still at -2. I'm going to look at the effect that the B variable has, and John and I were talking about this before, and we think it's kind of an interesting one to look at because a lot of people would know, what A does and what C does, but not necessarily what effect B might have. So I want to keep that trail on, but I want to kind of manually control how fast we're going to be looking at this. So if we now go into graph again, and we can see that when we've got, A -2, B -2, and C -2, we have no solutions. And I think one of the important points for this would probably not be maybe to start where all the values are the same, just because students might think then that if they're all the same, that means that there's no solutions. Whereas obviously we know that's not necessarily going to be the case. But if we tab through kind of one at a time, we can look and see how the number of solutions are going to change with our changing B value. And I'd probably stop this here and let students kind of think about it and say, all right, well, when are we actually going to have a solution? And hopefully they'll make that connection back to thinking about quadratic formula and what they've done just in class the day before. So we are going to see obviously one solution at 4, and then we'll see as we increase that when we're going to have our 2 solutions. And I think that's a nice visual of how that actually works.
And the other thing with the...
Yeah, absolutely. So this is a nice thing about, I think, having this on the screen where you kind of manually control the speed, is that it does allow a lot of those talking points, and then we can go backwards as well. and I think that trail is really good as well in this kind of case where you're seeing all of those solutions. And it's so, I think it's so nice, like how symmetrical it is too. So you can kind of talk to students about that and how you're, and at what point you're going to have the two solutions and what the connection that's going to be, what that's going to have. Okay, the last thing I was going to talk about with transformation graphing app is just a little bit of an extension into Year 12. And so I'm going to plot here a cubic with a repeated root and one additional root. And I should just say, this isn't one of the preset equations. They do have some cubics, but this isn't one of them. And one of the really nice things about the transformation graphing app, and just with the regular function editor on the TI-84, is that we can plot derivatives of equations. So I can take the derivative, and I got to that derivative, I should just say, just by going to alpha F2, which is one of the quick keys. And then alpha F4 brings me up to all of our y variables, and I'm going to hit y1 in there. So that's going to take our derivative of y1 with respect to x. And I'm just going to, I did this before, so I know I've got to change up my window a little bit. Yeah. Cool, okay, so there we can see we've got our cubic with the repeated root and we have our derivative. And this, I know, is a really, really common type of SACE question that they do ask in the Year 12 exams, is talking about the relationship between a derivative graph and the original function and even a second derivative. And I think it's something that I know my students really struggle to visualize. And they also really struggle to visualize with how this changes and how your derivative changes with different transformations of functions. So we can see here, I think I should still have the step turn, the trail turn on, yep, and we're still increasing by 1. But we can see here by adjusting that, that value of b, what's going to happen to our derivative graph and how our turning point and our points of inflection and the intercepts change with the changing derivative. Okay, and I think that's just about it for me. John, did you want to add anything on here?
Yeah, I think I used this app the other day with my Year 10s. We're doing trig transformations. And I haven't taught it this way before, but I actually showed them the app, and they just chose whichever trig function they want to look at. I think most of them chose cos or sine. Although we did then progress on the term, and that was quite interesting, where we had the asymptote and how the calculator copes with that. And then I just said, well, where could we put the variable? And we just chose one place to put it. So we didn't have it, all the letters to start with, just literally having a cos x. And they thought that was awesome. And they then started asking the questions about different ways that they could move that variable, and then blending variables. That obviously got to that general form of sine bx plus c plus d. And they started coming up with all the rules themselves, all the reasons themselves about those transformations. When I say reasons, I don't think we had to talk about why they were happening and what the cause of that was, and we used table to help us with that. Obviously, you've got, you could just click the table above graph there, and they found that really beneficial. They thought the visuals of that with the, like I said, having the trace on was fantastic.
Yeah. I find, it makes the transformations really fun, whereas I found in the past it's quite a laborious process where if you want students to investigate it by hand, they have to draw all the graphs themselves, or they have to go through and they have to plot each of the different graphs and then compare them, whereas this one, they're just literally clicking across. So it's a much more, I think, modern way of looking at it.
Yeah, and I think also because they came up with the ideas themselves, I think they took ownership of it much more, and they were much more interested in what the outcome was. So I was really pleased with it. I haven't thought it like that before, but it went really well. All right, Isabel, while we're talking, I've pinched the screen back off you. I hope that was okay.
Go for it. Yep.
So thank you. And well done there. That's some nice feedback from people in the chat window. And please keep those comments and questions coming in, as we'll monitor it for the next 15 minutes or so while I'm talking. And I want to look at two things. One is defined and undefined functions, but the first one we'll look at is inverse. And obviously the inverse of a function is quite a key concept to get across to students. The visual aspects of the graphics calculator can really help, supported by the numerical data that the graphics calculator can produce. So when I was thinking about which inverse we should do, I decided on the simple one of x squared. I've always find this interesting about the students obviously quite happy with square root of x being the inverse of it. I suppose they experienced that first for most of them with Pythagoras' theorem. But this one is still one that they struggle with to remember that that's another one as well. And I wondered whether we sort of lead them down a bit of a path when we just use Pythagoras' theorem and don't talk about these two options. Or maybe we do it in year 7 and 8 when we talk about number and powers as well. So maybe it's just my issue. So if we graph that, I've just got it on the Zoom standard, which is minus 10 to 10. We can see that it doesn't look like an inverse, and I'm just more going to give you some hints here on how we could do it rather than sort of a particular way, and hopefully there's a few things that you pick up on here. I'm just going to change the window to be just in a bit more. I could use zoom in, but sort of quite like having control over it a bit more. So there it is there, and it still doesn't look great. So what I'm going to do is I'm going to change the second inverse one. I'm going to change the colour like Izzy showed a minute ago. And I said to Izzy earlier, I always go, there. I was just going to say I always go the wrong way. There you go, I got it first time.
Yeah.
And also, still should be obviously a reflection in that y equals x line. We know that should be the case. Again, depending on how you introduce it with your students or that comes about with your students. And it doesn't because it's a rectangular window, but with sort of square axes, minus 5 to 5 in both directions. So we can go zoom square, which will square it up, and we should now get this nice visual. And we could actually cut it a bit more if we wanted to sort of keep that shape. But we can nicely see that if I did put in the y equals x line, then we can see that it is a reflection in that thing. And I've actually done it before where I've actually, on the smartboard, got a piece of white A4 paper, A3 paper or even A4, drawn the blue one, and then folded it along that y equals x line, physically folded it, and students really like that fact, or reflected on that and showed how it becomes the other one. So that's quite nice. But what else can we do? Well, one obviously nice feature is what we could do in normal calculus is get them to the idea of function notation. So like Izzy said with the quick keys, F4, there's y1, which we know is the x squared, and we could choose any random number. Eventually we put brackets with this function notation. We can put any number we want, let's say 3.75, and we're going to get an answer. We could look at where that is on the graph if we wanted to. But if we then took y2 of that, and these are nice questions to ask the students, then what's going to happen? So y2 of answer, let's take that number that we had before. What's it going to do? Well, it's going to go back to the original number that we started with. So that's quite nice to get them to think about that. And we could also look in the same way at composite functions. If we did y1 of y2 of any number. So again, 8.3. What's that going to give us? Then we're going to see that it's going to give us just 8.3 because they're the inverse of each other. An interesting point would be that obviously if we took that one, so I just arrowed up and copied it, I'm just going to insert here with some students. So they went, how did you do that? So second ints in blue, the negative, then this isn't going to give us negative 8. Ooh, that's interesting. I'm not thinking. Because it can't square root the start with. So I suppose we could get round that by doing, so we could get round that by putting them the other way around, I suppose. If we did y2 of y1, then it would, oops, that arrow's not going to work without that. So if we do y2 of y1, and do it the other way around first. So those faults, notice I went to the go-to rather than the quit. I sort of rushed and panicked that without thinking too much. But the go-to, the students seem to miss for some reason, is a much better way because it takes them to where the error is, and they can actually work out just like a fault, I suppose, on a graphics on a coding program. So we can see that that's not going to give us the negative 8.3. That's because we're using only half of the inverse to y2 rather than y3. But obviously it would work if we use y3. So those are some nice little features. And I was thinking, well, how else could we progress that a bit further? Well, we could actually use the statistics page on this, and we could actually do a list of numbers in here and look at it visually in here rather than one number. To get a set of numbers, we go to the very top, sort of like putting a formula in for Excel, and we can do sequence, which is in list, cross to operations, and here it is, number 5, sequence. The nice thing with the new software is that it comes up with the sort of structure of it already. So the expression is X, the variable we're going to use is X. We want to start, we're just going to look at positives, we're going to at 20, and we could have, well, every half, I suppose, it would matter. And if we press enter now, it will put all those numbers all the way down. It should take me, there you go, to the bottom one if I wanted to arrow up and get to the bottom. That's one way of doing it. The other way, so press clear to clear that list. The other way that I thought about is maybe students would think, well, yeah, that's all well and good, but you're only actually looking at a specific set of numbers, like a linear increase of numbers. So how else could we do it? Well, we could change it in sequence and do it differently, but I thought that another nice opportunity would be to use math and go to probability. And we could use a random integer, and then we could do any random integer. The interesting thing was, so let's do any random integer. I haven't really thought about this too much, to be honest with you, minus 25 to 25, and let's do, say, 20 of them. And if we paste that in, we can see we get this random set of numbers that come up. And then we can come up to this one, and we can say, well, okay, we can take y1 of that. So, again, using the function notation, y1 of, and list 1 is just above the number 1 in blue. So y1 of list 1, and we can see that we get all those numbers. And obviously, if it's the inverse, then we could do y2 of all those numbers. But equally, only half of them would work out correct because of the fact that this is in those two halves. If we used ln and ex, then we wouldn't have that issue in the same way. But well, we obviously would when we're using the square root. But so I think that adds some nice discussion for students to talk about why that would be the case. So we're going to be doing y2 of list 2. Oops, not that one. Second list 2. Oops, got to put some brackets in there. So list 2, and we can see that it's going to take us back to the starting place again. Is there any other ways that you actually show that when you sort of explain to students about the inverse?
No, because I think we were talking about it before, and one of the things about the SACE curriculum is that you actually don't, you talk a little bit about inverse functions, but you don't talk a huge amount about them. So I haven't actually done much teaching of inverses. But no, I don't think I would do it in a different way.
Yeah. I think also we've got hopefully I know we've noticed I've got a couple of Queensland people with us, so thank you for joining us. And equally within the IB that this calculator can be used there, and obviously it would match across quite nicely with some of the function notation that's used in that. So that's great. So that's the inverse. And if we now look at defined and not defined functions, I think you always have your sort of questions that you like to go to. And one that always sticks in my mind, and I sort of dug it out, was an old SACE question. I'm just going to go on to change those colours back. Yeah, I may just set those colours back. So into men, I'm just going to reset and default all the settings. So I'm just going to reset all that for me. Now we're going to put all the colours back to what it was before. The question was, and this was from 2011 Math Methods, the first question was this. And we're all okay?
Yeah, sorry.
You
I couldn't hear you for a second. It's all good. Yeah, I did, yeah.
It was so strange that I wasn't talking. That's why you panicked, didn't you, for a minute?
I know. That never happens.
Thanks, Liz. And it said equals 0 on the end. And it says find the value or values of x such that that equals 0. So a really nice question, only 1 mark at the very start. I mean, it caught a lot of students out. If we do go Zoom standard, back to the 10 by 10, we can see that. And I think straight away some students said, well, it never does equal 0. So a lot of students said, it doesn't equal 0. But other students were thinking of other ways that they could do it. We could do zoom box. So if we go to zoom box, we've used this before, it's a really nice little feature, and we can move literally like a magnifying glass, so we can actually just zoom in a bit and almost hit the bottom of that. Oops, I didn't press enter. So we go to one place, press enter, and then we move across, and we come down off that line, and we're sort of only going to see the tip of it at the moment there. But if we press enter on that, we can see a lot more of that line. So obviously, it's more to do with the pixels, and I had a really nice conversation with my year 11s the other day about the pixels and talking about how obviously it's trying to move across mathematically to the next place, and numerically it is, but the pixels are sort of, and the calculus sort of starts to freak out about what happens there. So again, does it get that reach down the bottom of there? Well, we could do zoom box again. I'm not going to do that. So it does look like, I think that some students would even say that it hits at -3 because of the fact that they used to sort of, some of these graphs stopping short because of the pixels. But what you sort of wanting them to do, and I did this earlier and thought, oh, well, that's easy. All you could then do is ignore the square root. And if you take the first one, so y1 and then square it, then you should be able to find out where it crosses. Again, if you practice these sort of things before you use them with the class, or even if you don't, it doesn't really matter. So if you don't, or you think about what that's going to give you now, and you graph it and go, oh, wow, no, it doesn't. It's almost like a logistics curve, perhaps. Maybe it's asymptotic there. It doesn't go any further because that's what the red one is causing as well. But we can see that if we think about it, and as we, again, great discussion with the students, that because this one has no values less than a certain point, we can see that in the table. If we scroll back up, we can see that gives us an error here. And maybe, again, students think that it doesn't equal to -3. A nice little feature of the new OS is, if you see up here, it says just above the table, I've got my cursor there, press the plus key for the increase. We could look at increasing it by, say, 0.1. So we can see that, yeah, it doesn't work at 0.29, but it does work at 2.8, 2.9, 2.8 negative. So I wonder what would happen if we change the increase again to 0.1. And again, we get all these errors, but we can see that's actually starting to work here as we get closer in. So it's looking like it's somewhere around about 2.85 and 2.84. So it does look like it may get to 0. Maybe it doesn't. But the reason is because there's no values here for y1, when you're trying to square them, it's not going to give you any values for y2 at that point. So we'd have to, therefore, retype that in. X cubed. I'll talk this time, Izzy, so you don't think that the mic failed. Plus 6. And if we graph that, then we can see that it does cross, and we can then find the intercept. So second calc, intercept. We've got to move the cursor, so we're not on the blue curve, we only want the intercept of the red curve. So we're on the red curve, we're going to move to the left-hand side of that. So I'm normally a bit lazy on that, I'm just going to type in -3. Oh, that was interesting. Let's try that again. Second calc, not the intersect, that's why. The 0, that was a bit silly.
Yeah.
Not the
I was
blue curve.
I was going to say.
There you go, -3. I'd be interested, I wonder if you would get intercept at that point. Or would it even give you a value? -2. This is nice to say that's in between those two. Yes, it is. And there's the value. So the nice thing is that that's stored on the calculator. So if we press X in this mode, we can get that number back. Notice that it shows us much more on this screen. It's the same number. We could store that as a different letter and use it later if we needed to. I just wondered whether, Izzy, what do you reckon? Do you reckon it's going to work for intercept? Or do you say that since the blue one actually starts at 0, it wouldn't actually intersect?
Oh, let's try it, damn it. I want to say yes, but I think it should be no.
I think it's going to be no as well. So we've got to move it close. If we move it, so just people who haven't used this functionality before, if we come, where have I gone? There you go. If I come over here, it's going to give me this intercept here, and if I come over here, it will give me the second intercept. I wonder if I come back over here, whether it will give me this one here. I'm not confident. Wow. There we go.
There you go. But it's not at that same point that we found before.
I wonder if we zoom in whether it actually would change that number as well. So there we go. I also was thinking that it's nice then to think about the app. This is one of the apps that, again, the students use a lot, and exam boards know that is available for them to use on the calculator. It's PolySimp. So we could go into Polynomial Root Finder. It's a cubic, so we would go to 3. Notice what Izzy was talking about before, about the tab buttons and where they are. So it follows across. So we're going to go to Next, which is this button up here on Graph. Izzy showed that a minute ago. And when we type that in, we've got 1, enter. There is no x squared, so that's okay. We'll leave that as 0. We're going to use the take away button on this, or you could type in the number as negative here and leave it as positive. That's the other way around. 6 and positive 6 again. And if we solve that now, again using the 5 buttons on the top, we're going to use the solve one. It gives us that number. We've already got that number a different way, but if students wanted to use that, they can store it, and they can store it into a list. So we'd have to choose which list. We've got to choose which list we want to put into. If there's numbers already in the list, we can't store it. So we go into list, and let's store it in list 6. Hopefully it will work. There you go. It's stored it in list 6. So if we now go to main and quit the app, over in our stat, over in list 6, there is that number. And again, a nice little feature is if we do a bit like Excel, list 6 of position 1, then it will give us that same number. We can see that that's the same number that we got using the 0. And then we can actually do something with that number. The nice thing with that question is then went on for 4 marks, believe it or not, for 4 marks to graph it. And it asked it to accurately mark any axis intercepts and any stationary points between the points -3 and 3. So it gave you the axes going up by 1 and -1. And having been a marker in the past, I think it always upsets me. I'm just going to turn the other one off. So you come down on top of it where there's a black square and just press enter, or a black rectangle. It always upsets me that students can't draw that accurately. There really is no reason when they got the graphics calculator to not draw it accurately. Yes, they may miss this one. We now know that it goes down here to negative 2.84, but there's no reason why they shouldn't be able to draw the rest. Intercept's very easy. Second calc, a value at x equals 0, or they could go into table and find that value, and finding the max and min is the same, just using left and right bound like we did with the 0. So I'll let you have a play with that functionality. And the last one I'd like to finish with before I pass back to Izzy is one that Izzy mentioned, and fraction button, we can just do rest alpha x. We're going to use a fraction of sine x on x. And it's in radians, so I'm happy that my window, I will just do zoom standard for now. And this is a nice one to say, okay, where is it defined and where is it undefined? Because really it looks like it's defined the whole time. I think that students may think that it is because it's a sine curve. Hopefully that we've all taught them well enough that they know anything divided by 0 is going to give an error. But it's a bit tricky to see on here. So a really nice idea that Izzy actually mentioned to me, I'm pinching this one off Izzy, is we could go into format and we could change the axis color. And if we change the axis color from black to, there you go, there we go, to white.
You've gone the wrong way.
Yes, thanks for pointing that out. I didn't. And we can see that it does give that break in there, and we can see that there is a break in the pixels, so the axes are white. In fact, I've just thought about that. No, that's not what I wanted to do, was it? Because if I make them white, that actually is still going to, it could still be drawing a white line over the top. If I turn the axes off, that's much better. That's what I wanted to do. Axes off. So if the axes are off, there's no white line there. There's no nothing happening. No nothing? Double negative. Interesting. So there you go. There is definitely a break. If we go into table, and we can see it's still set up from before, so that's a bit of a nightmare. Let's go into table set. We'll start at 0, going up by 1. go back to graph, and, go back to table, we can see now that it does give an error here. And then, again, I think we could either do it in normal calculator screen and do some sort of function notation with y1, but I quite like doing it in the graphing screen, that if we chose a value very close to 0, let's say 0.1, that we can see that it does give us a value. Obviously then students normally, and perhaps I will do it in normal calculator screen to show a similar sort of approach, that students would then perhaps go, oh, I wonder what happens if you go to 0.0001, and we can still see it gives a point. And some students may even go, well, what's the biggest number you could do, or how could you get it? And we can link it quite nicely with normal distribution and say, well, okay, what we actually could do is e to the negative 99 and talk about what that is. So we do that by e is on the comma there, negative 99. And again, talking about what that gives us. It actually gives us 1, interestingly, and talk about why it does that. Because if we do y of 0, so let's just go off and copy that one. Let's just delete those couple. We will see that it gives us an error. We can't divide by 0. So again, go to it, and we can see that we can't divide by 0, so that's why the error is there. Izzy, have I missed anything out that you think you should add to?
No, I was just going to say I quite like looking at this particular problem as well, just from the table perspective. And again, looking at that and changing that the table, and we can see that that error really does only occur in the one place. And I like this because it kind of introduces students to the idea of a limit quite early, so you can talk about, even though we have an error there, what are we approaching, and looking at it from both sides.
Yeah, nice. Yeah, very nice. Very, very nice. Like you said, just changing it on the ear. In fact, if we go to that small, we're getting very close on either side. Excellent.
Yeah.
Right, well, I'll pass back over to you and make sure I press the right button this time. All over to you.
Cool. Okay, so the last thing that I was going to talk about is just a bit of an application of using an image that we can put into our function editor and use it and fitting an equation to that image. So John mentioned it before. I'm on SmartView, and if I go into this Explorer, I have it's very slow. I have an image here, image 7, and I've dragged and dropped that from my desktop. So when I go into Format, and I get to that by second zoom, and I go down to my background, I can change the background of my graph to this image 7, which is not a preset image in the calculator. You need to download that from Google, but you can grab any image you like. So I'm going to set that. I've got a DNA double helix. Because there's that black background behind it, I'm just going to change the axes to green and hit graph. And now I can see I've got my double helix behind my axis, and we can actually see that, which is good because we wouldn't be able to see it if it was black. The last thing I want to do is I actually want to be able to line up some of my X scale with the bases. I'm not going to be able to line them all up perfectly because they don't all have an interval of 1, but I'm going to try and match this one up, and I reckon by moving my graph 0.5 to the left or to the right, I'll be able to see that. So I'm going to go into Window, into my Xmin. I'm just going to add on 0.5 and graph again, and now I can see I've got those bases lined up with the X scale. All right, the other thing I did just before was in list, I found, and I did this by hand, I found some of the points along the double helix, so I'll just show you what that looks like. So in here, I've plotted these points, and if I was running this in class as an activity, I'd definitely be getting students to do this themselves, and then we'd probably be finding the transformations by hand rather than using a regression. But for the moment, I'm going to run a sign regression of those points that I plotted. So I have one iteration, X list 1, Y list 2. I'm going to store that into my Y1. So again, we can go alpha F4, get the Y1, and calculate my regression. Beautiful. So there's our function. in y equals, I'm just going to change this to yellow, and I'm going to go back this way, yes, and get to the yellow one. And now I should be able to look at that graph, and we can see that, oh, hang on, sorry, I've still got my y set on 50. I'm going to change that to 10 because that's what I used for my points earlier on. And there we go. We can see that that equation kind of nicely fits that red part of the double helix. The other way that we can do this, and when I usually run an activity like this in class with my students, is I'll get them to do this first one by hand. And then one of the really nice things that's come out on the 84 recently is this quick plot function on our stats editor. So if we go into stat across to calc, and again, it's the very last one in the calc menu, so I'm going to go up. We can see we've got quick plot and fit equation, and that lets us kind of drag and drop points into our graph screen and then fit an equation from those dragged and dropped points. So if I hit enter on that, we can see here it's going to say drop points, and I'm just going to quickly add in a few points along that line or along that red part of the helix. It's nice to talk to students about this, about how many points they need to have. I always tend to do more probably than what I need, but I like that security of knowing that it's probably going to be as accurate as possible. So I'm going to do quite a lot. But it is really, really quick to do, and it's nice and easy. And one of the things I've found is that with students that actually the equations that we find by hand are pretty much as close as possible to the ones that the calculator generates, which is really nice, kind of reaffirming for them that they're on the right track. Okay, so if we now go to fit equation, which is that button down there, it's the same as the graph one like we were doing before. If we hit graph, I still want to do a sign regression. So we can go down to A, hit enter, and we get our sine curve. And we can see that actually it's pretty close to that yellow one that we did from the regression, just from the hand plotted points as well. So I'm going to store those results. I'm going to store, I want to store this into list 3 and list 4 because I've already got that other stuff in list 1 and list 2. I'm going to store my equation into y2, hit OK. And now, just because I'm a bit of a pedantic person, I'm going to change this to red so it's the same color as that double helix that we're plotting in my y3. I'm going to change that one to blue. And now I've gone the wrong way. Into blue. And I'm going to take the reflection of that y2. So I'm going to go negative alpha f4 and y2. And now I should have a nice blue and a red curve showing the double helix. Okay, the last thing I was going to do is just show quickly, say we wanted to run a bit more of a study onto this and we wanted to work out, say, what's the distance between, for that base there, we can see that that's at negative, so I'm going to have to count them because they are quite hard to see, maybe 1, 2, 3, 4, think about negative 5. So we're going to look at that base there at negative 5 and I'll say what's the vertical height between those two there. We can go back into our home screen. We can look at our y3 of negative 5, and that's going to be our top blue curve, and we can take our y2 of negative 5, and we can see that the difference between those two curves is about 5.6, so that would be the distance between that red and that blue curve there. So I think you could probably run quite a nice biology investigation into this. Obviously, if you wanted to make a 3D model, you could do some really nice maths about from this and kind of compare the 3D model that you make to the graph as well. Okay, I think that was pretty much all I wanted to say.
That's great, Izzy. Yeah, fantastic. And I really like that little at the end, just to look between the maths. A different way of doing it as well. Obviously, you could use the calculator, but I think doing it with that function notation is a really nice way to go about doing it. Yeah.
Yeah. I was trying to find, actually, when I was looking for something for this, I was trying to find a nice double helix where you actually had to do, where they weren't completely symmetrical, so where you had to do a bit of a horizontal or a vertical translation as well, and I just couldn't find a nice one that worked, but maybe someone else could, and they can send it to me.
They can send it to you. I like that idea. All right, I've got one thing for you to fix with, and put you on the spot. So I want to go to TI Connect. Actually, just before I do, what I gave the students this activity, my year 7s, to come up, because it was Valentine's Day the other day, to come up with their best image for Valentine's Day. And you can actually share those images with each other once they're made using the link functionality. I can't use it on here because this is a software, but if you actually look here, there's a really nice function for a link. You probably wouldn't use it too much for the image because it's actually just using the graphing screen. So you could actually transfer the Y values if you wanted to. But the link functionality is really useful if you want to send lots of values in lists or students to create programs in the coding scene. So just be aware of that using a mini USB to mini USB cable between the two calculators. So we're going to go to TI Connect because I've actually got it on the calculator for me, and also I thought that we could show as well. So I'll take a screenshot of it. So there you go. That's on the calculator screen. There you go. So what do you reckon? How do you think the student made this one?
Oh, I'm gonna assume that your axis is running in between the heart through the center there. I'm one of these people. I need to be able to do something. I really struggle with just kind of looking at it and working it out.
It's something that we're not like live or anything like that at the moment, isn't it? Like,
no, I know.
To impress other people that are there. Perhaps any of the people that are actually watching live could actually add in the chat window what they think actually happened on this one. So while they're thinking about it, when you actually do these and you use, so I've got a student at the moment working on one of their math assignments. So don't forget any of these images or the equations that you get, you can copy those and put them into a Word document quite easily by copy and paste. You actually don't even have to do copy and paste. If you actually have your Word document open, you can actually, oops, that's not going to work because it's too big. If I stroke that down a bit, and had the Word document behind me here, we could actually drag and drop it onto the Word document easily. And also actually the same works on Smart View. Just be mindful, if you didn't know, that when you've got a Word document open there, that you could actually also drag and drop. Let me just get to a clean page on this. So I'm trying to rush this here. Let's get rid of that one on my Word document. Get rid of that one for a second. We can actually also drag and drop the Smart View across. So if there was actually something you want to teach students and make a little handout, you could do it that way, or rather than the video. So any other thoughts, Izzy? And you see anything in the chat window?
I can't see anything in the chat window for the moment. The only thing, I'm going to assume you've used, you've either used piecewise, which I don't think works for an inequality. So I think you've used an absolute value for the bottom part of the heart. And I think you've done. I'm going to say you've done less than for the absolute value. Just because you've got those two different patterns from the quadratic. And
yes, very nice. It's actually not a quadratic, but you've done a great job. No, it's
semicircles.
not.
Okay. No?
Yeah, two semicircles.
Two semicircles. Okay. And then I think you've done greater than for one of the. Oh, I don't know. It's the two different patterns that are throwing me off.
Yeah, that's right. Well, I think you've done a great job there, Is.
I don't think I have, but there you go.
Izzy's also mentioning that you could do greater than. There's a nice app on here for inequalities, number 7. Inequalities. I highly recommend that you look at that one as well. But yeah, I've taken the screen, so I'll take another shot so you can see the other one. Here it comes. So that's what we did. There was two semicircles. Obviously with diameter 3.
They're white.
And we made them white because then, if I just go into format, and you can see it if I take another photo in format, we actually made the background red and turned the axes off. So rather than actually colour the heart, we actually coloured the opposite inverse of the heart, I suppose. So you had to pick well. So we can actually change the zoom a little bit. You did quite well that the sort of pixels or the directions of the pixels are all different for those three. So yeah, there you go. Nice little activity and quite a nice variety of ways that this one could be done. But like I said, I like the idea of the quadratic as well. That could work quite nicely.
Do you know what? Like the other way, I guess you could probably run this as well, which my Year 11s really enjoy making patterns and colouring them in, is to kind of introduce the integral function to them as well, without them actually really having done any integrals yet, and that could potentially work as well. Yes,
I think that'd be a great way to go. Yeah, excellent. All right. Well, on that note, and well recovered, Izzy, I was impressed. We're going to begin wrapping things up. So if you do have any last-minute questions, please try and get those asked. I know Izzy and I will endeavour to answer them. Equally, we will monitor them and add them to planning of future webinars. When you leave the webinar tonight, a brief survey will automatically appear here in your browser. Your feedback guides us as we plan for future online events, and we do listen to feedback. So please, we do hope that you share your thoughts, as long as obviously they're positive. Just kidding, however you want. To post in the post-webinar survey. Your certificates of attendance, so hopefully you can use that for your TRB, will be emailed to you in the next 48 hours, along with the link to our on-demand and YouTube version of the recording, as I mentioned, and any relevant documents. I don't know if we're going to actually include anything, but if you would like any of the documents that we've used today, then please just ask via the email that you'll see in a minute. Please share these with your colleagues. After we leave tonight, if you do need some post-webinar follow-up, as I said, please feel free to phone TI Australia or email them. And I know they'd love to hear from you, and they equally will put you in touch with trainers, all practicing teachers all over the states. And that, sadly, brings us to the end of tonight's webinar. Izzy, thank you very much for everything you've shared with us.
Pleasure.
I know I have, and the participants, I'm sure, from the feedback that I've read, really appreciated it. And equally, thank you, everyone who's joined us tonight. We do run these webinars hoping to hope you learn something and to enrich what's happening in your classroom with your students. So I hope you found it useful. Please give any feedback, positive and constructive, that you want to give. And we hope to see you back online again soon. Thanks very much, and good night.
Bye.